So we have a radius that's increasing at 1 meter per 30 seconds. Okay, so which translates into 1/30th of a meter per second. So that's the rate of change. Construct a table of values that shows the area of this oil spill at 2-minute intervals for 30 minutes. Okay, so that's time. This is the radius. At 0, let's say 0 at 2 minutes, right? This times by 4, so it's gonna be 4 meters. Okay, at 4 minutes, it's gonna be times by 4 again. You're gonna be adding 4 again, right? So at 4 minutes, it's this times by 8, so it's gonna be 8, right? 6, we're gonna be adding by 4 again. So that's the pattern. Okay, etc. Determine the average rate of change of area during each interval. So that's the radius. The area is going to be pi r squared. This is going to be pi 4 squared. This is pi, 8 squared, pi 12 squared, pi 16 squared. This is 16 pi, 64 pi, 144 pi. So 256 pi. The average rate of change from 0 to 4. Okay, 0 to 4 is 64 pi minus 0 over 4 minutes. Okay, so that's 16 pi. And that's meters squared per second. First 10 minutes, it's going to be pi, instead of 16, it's pi 20 squared minus 0 over 4. Not 4, first 20. First 10, right? This is the first 10. So it's going to be 400 divided by 10, which is 40 pi meters squared per second. 30 minutes, it's going to be pi. Do you see how this radius is doubled of this number? So if 30 minutes, it's going to be 60 squared over 30. So it's pi 60 times by 60 divided by 30. That'll reduce to give you 120 pi meters squared per second. Okay, part C, what is the difference between the instantaneous rate of change of the area of the spill at 5 minutes and 25 minutes? So for 5 minutes, you want to use these two data here, between 4 to 6, to estimate the instantaneous rate of change. So 144 pi minus 64 pi over, 2 minutes. It's 125.6 meters squared per second. And for 25 minutes, you want to estimate it using the area at 26, 24, and divide it by 2 minutes. So 26 is going to be pi, you got to double that, so it's going to be 52 squared. Double that is pi 48 squared all over 2. I guess 628.3 meters squared per second.